Hello everyone, and welcome back to the good stuff we have been doing. Today in this video we have an interesting integral before us to solve, and it says we should evaluate the integral from 0 to pi over 2 of x divided by tan of x dx. Now we're going to use the fact that from in this interval 0 to pi over 2, it is possible to write x as tan inverse of x, tan inverse of tan of x. In fact, tan inverse of tan of x equals x on this interval, and we're going to use that and write this as the integral from 0 to pi over 2 of what? Tan inverse of tan of x all divided by tan of x dx. So next, what we do is that we use the fact that tan inverse of x is equal to the integral from 0 to 1 of x divided by 1 plus x squared y squared dy. Okay, now for that you will have to write this as the integral from 0 to pi over 2 of 1 over tan of x times the integral from 0 to 1 of what? Tan of x divided by 1 plus t squared times tan squared x, then you have dt, and then you have dx. So this method here, I would call it the double integration technique. But then you should understand that there is another method you can use to solve this, and that is the King's property, the fact that the integral from a to b of f of x dx is the same thing as the integral from a to b of f of a plus b minus x dx. So there are several ways to solve this problem. I'm going to just pick this double integral method because I feel like it's what I prefer the method, so much more relatable to me. So let's proceed. Notice that the tan s cancel out, so you end up with the integral from 0 to pi over 2 multiplied by the integral from 0 to 1 of what? You have a 1, then you have a 1 plus t squared tan squared x, then you have dt dx. So next, notice that of course the substitution to makeness is clear and self-evident. It's to take t to be u to be, say, tan of x. Then notice that if we do that, the u would be secant squared x dx. So basically, let's multiply top and bottom by secant squared. You get the integral from 0 to pi over 2 times the integral from 0 to 1 of what? Secant squared x all divided by 1 plus t squared tan squared x. Then at the bottom you write 1 plus tan squared x, because you know that tan squared x, 1 plus tan squared x is secant squared x. So you have a dt and then you have a dx. So if we proceed, you end up with this integral from 0 to notice that if we take u to be tan x, when u is 0, you have, when x is 0, u will still be 0, but when x is pi over 2, u becomes infinity. So you have integral from 0 to 1 times integral from 0 to infinity of what? Of du divided by 1 plus t squared u squared times what? 1 plus t squared. Then you have dt du dt. Now we need to put this in partial fractions. So you will have the integral from 0 to 1 of 1 over, so everything would be in terms of u now. So we have to write this, let me see, you have to, if you do partial fraction, you have to write this as say u squared minus 1, and then you over here you have the integral from 0 to infinity of what? Or 1 over, so you have u squared all divided by what? 1 plus u squared t squared minus the integral from 0 to infinity of 1 over 1 plus t squared. So this is what you will get if you do partial fractions and you have du over here. So over here, then next up you have the integral from 0 to 1 of 1 over u squared minus 1 Okay, then this side here, notice that this is going to become u times tan inverse of ut. Okay, and over here, well, this is going to also become tan inverse of t, and everything is from 0 to infinity. So from infinity you get pi over 2, and then from 0 you get 0. So you have a u. So you have the integral from 0 to 1 of 1 over u squared minus 1. Then you have a u pi over 2 minus pi over 2. So you have a pi over 2 and u minus 1. So you have the u. So that would be integral from 0 to 1 of, let's say, pi over 2. So you have a u minus 1 divided by a u minus 1, then a u plus 1 du. So this cancel out. So you have the integral from 0 to pi over 2 of what? Du divided by 1 plus u, then which is pi over 2. So you have pi over 2 times log 2, obviously, if you do the basic integration. So that is that for this part. So thank you very much for watching, and please do subscribe to the channel. Bye and have a nice day.